Today I want to show you a Rust app that does something really clever. It teaches Rust by being a Rust program. This is not just a slideshow about syntax. This is an actual desktop app with real structure, real state, real modules, and real user interface flow. Even the entry point is educational. The main.rs file is intentionally kept small so beginners can clearly see the startup path, configure the native window, create the app state, and hand control to the event loop. That is already a useful Rust programming lesson because good Rust projects usually separate startup from application logic instead of dumping everything into one file. And that theme continues through the whole app. As you use it, you're not only learning concepts like variables, functions, and modules, you're also seeing how those ideas show up inside a real codebase. The app's shared models live in one place, the content is separated from the user interface, and the top level app struct owns the cross screen state. That is a very Rust way to think. Clear structure, explicit state, and predictable relationships between pieces. So, the big promise of this project is simple. If you download this code, build it, run it, and work through the concepts, you're not just reading about Rust, the programming language. You're actively moving closer to thinking like a Rust developer. Now, this app is trying to make you dangerous in a good way. It walks through concepts like variables, functions, ownership, enums, traits, and cargo. That means by the time you download this code, build it, and run it, you're already stepping into territory that most people never even touch. And honestly, that puts you in rare company. Most people will never learn Rust, the programming language, at all. So if you can run this app, follow the guided path, and understand what it is showing you, you already know more about Rust than 99% of the population. That is what this video is about. Not just what the app does, but why this is just such a powerful way to learn the Rust programming language. If you're enjoying this content and learning about Rust, like and subscribe right away. When you open the program, you enter the Rust Concepts Explorer. The app starts you on a guided path instead of leaving you lost. There's a sidebar that literally tells you to start at the top and continue downward, and it tracks which concepts are new, opened, or completed. That is important from a teaching perspective, but it is also a nice example of Rust state management. The app struct stores things like the current screen, the current tab, the set of opened concepts, the set of completed concepts, the active visual mode, and the ownership mode. In plain English, one owner, one central state object, and the user interface renders based on that state. That is classic Rust architecture thinking. And right there, we can tie in the first Rust concept, structs. Let's see if we can find a struct. Oh, right here. Right here, struct. All right. Struct and Rust is how you group related data together into one meaningful unit. This app uses that idea everywhere. The Rust Concepts app struct is basically the brain of the program. Instead of scattering values all over the place, Rust encourages you to model related information together. That makes the program easier to reason about and harder to break. Now, the teaching content reinforces the same idea by explaining that structs are for modeling your domain cleanly. And as you move through the app, each concept has two major tabs, explanation and code. That split matters because it reflects another important Rust learning habit. Understand the mental model first, then understand the syntax. The code tab does something especially useful. It gives you clickable teaching snippets that show a base example, then an updated example with changed lines highlighted. So, instead of overwhelming you with too much code at once, the app teaches small deltas. That is perfect for learning variables and mutability. Now, Rust variables are immutable by default. That means if you write let score equal 10, Rust assumes that value should not change. If you want it to change, you must explicitly say let mute score equal 10. That the app has a snippet that shows exactly that progression, from a plain binding to a mutable binding with score plus equals to 1. This is one of the first moments where Rust feels different from many other languages, because mutation is no longer casual, it is intentional. Now, the next important concept is functions. Rust uses function, or fn, I should say, to declare functions. And functions are one of the first places beginners start seeing Rust's emphasis on clarity. Inputs are typed, outputs are explicit when needed. And sometimes the final expression becomes the return value without needing the word return. The code walkthrough in this app even pauses on FN and explains it in plain English as a reusable behavior block. That is great because it helps a learner stop seeing syntax as decoration and start seeing it as meaning. Then the app moves into types, which are a huge part of why Rust catches so many mistakes early. The teaching content explains that Rust checks types at compile time, which means the compiler can stop invalid operations before the app even runs. That is a big reason Rust feels strict at first but rewarding later. If you know the type, you know the rules. So when the app shows things like I32 or bool or tuples and arrays, it is really teaching the viewer how Rust understands data. And from there, the app gets into one of the most important Rust ideas: ownership. And this app does a nice job of not treating ownership like some abstract, scary theory. It gives you a dedicated ownership visualizer with modes for move, immutable borrow, and mutable borrow. In the move example, a string is transferred from one owner to another, and the old owner becomes invalid. That teaches a crucial lesson. In Rust, heap data, like string, is not casually copied around. Ownership moves unless you explicitly borrow or clone. The app even states the compiler protection directly. Use after move is blocked at compile time. That leads naturally into borrowing and references. Borrowing is Rust's answer to the question, how can I use data without taking ownership of it? The app teaches that or that ampersand and T is an immutable reference, and ampersand mute T is a mutable reference. You can have many readers or one writer, but not both at the same time. In the visualizer, immutable borrow shows multiple read references coexisting safely, while mutable borrow shows exclusive access. That is one of the core safety guarantees of the language, and the app makes it visual instead of mysterious. Another strong concept in this app is enums. Enums in Rust are much more powerful than a lot of beginners expect. They are not just labels, they are ways to model valid states inside in a type-safe way. They're not just labels, they're ways to model valid states in a type-safe way. The teaching content literally gives an example like idle, loading, and error string, which shows that one variant can even carry data. That is a major Rust idea. Instead of using random strings or magic numbers to represent state, you model the possibilities directly in the type system. And once you have enums, pattern matching becomes incredibly valuable. Rust's match is one of the language's best features because it forces you to be explicit. The app explains that match is exhaustive, meaning Rust wants every case handled. That's not just a syntax preference, it is a reliability feature. If your state has 3 possible forms, Rust wants you to acknowledge all 3. The content also shows pattern matching with option, including cases like some, v, and none, which is a way to introduce the idea that absence is a real state, not a hidden bug. That connects directly to option and results. Alright. This app teaches one of the most Rust-specific ideas in a very practical way. Absence and failure are represented in the type system. Option T means maybe there's a value and maybe there is not. Result T, and with a comma and a E, means maybe this worked and maybe it failed. That is a big departure from languages that rely heavily on nulls or hidden exceptions. The error handling section also demonstrates the question mark operator, which is one of the nicest parts of Rust because it lets you return early on an error without writing messy boilerplate. The app also does a good job teaching modules, which is where beginners start seeing how Rust projects scale. Modules. All right. The content explains mod, pub, crate, and use, and that matters because these are the keywords that define structure and visibility in a Rust codebase. Mod declares that a module exists. Pub makes selected items visible outside the current module. Use brings paths into local scope so code stays readable. Crate with 2 semicolons refers to the current crate root. The app even includes an interactive path visual and examples showing how Rust maps module declarations to files and folders. That's not just theory. This project itself uses those rules. Main.rs declares modules. User interface has its own mod.rs. And shared data types are exposed through models. That makes this project especially useful because the codebase itself reinforces the lesson. For example, the comment in models.rs explicitly says that keeping shared models together helps beginners see how enums and structs become the common language between modules like navigation, content, and user interface. That is exactly how a real Rust app grows. Not by throwing everything into one file, but by giving each part a clear responsibility. Later in the learning path, the app introduces traits and generics. This is where Rust starts feeling really expressive. A trait defines behavior, and a generic lets one piece of code work with many types while staying type safe. The content shows a trait bound like T:(summary, which tells Rust this generic type is acceptable only if it supports this behavior. That is powerful because it lets you write reusable code without giving up compile time and guarantees. Then it touches lifetimes, which beginners usually hear about with some fear attached. But the app presents them in the right spirit. Lifetimes are mostly compile time explanations of how long references are valid. They do not change runtime behavior. They document and enforce safe reference relationships. That is an important teaching choice because it helps viewers see lifetimes as a reasoning tool instead of magic syntax. And finally, the app includes cargo basics, which is essential because cargo is the standard workflow engine for Rust. The teaching content shows commands like cargo, new, cargo run, cargo check, and cargo test. That matters because learning Rust is not just about learning the language syntax. It is also about learning the tool chain that makes Rust development practical. So when I say this app teaches Rust, I do not just mean it has Rust words on the screen. I mean the program structure teaches structs, enums, and modular design. The interaction model teaches state. The ownership visualizer teaches moves and borrows. The examples teach mutability, functions, and type safety. The error handling section teaches results and the question mark operator. The module section teaches how Rust code bases are actually organized. And cargo ties the whole workflow together. That is why this kind of project is powerful. It is not a fake toy. It is a learning tool built as a real Rust application. What I like most about this app is that it teaches Rust in two ways at once. First, it teaches the concepts directly: variables, mutability, functions, types, ownership, borrowing, enums, pattern matching, error handling, modules, traits, lifetimes, and cargo. Second, it teaches those ideas indirectly through the structure of the app itself. The code is modular. The state is explicit. The relationships are clear. The design reflects the language. So if you download the project, build it, run it, and actually work through the guided path, you're doing more than consuming a tutorial. You're learning how Rust thinks. And that is the real win. And knowing is half the battle. Because once you understand why Rust uses ownership, why it models state with enums, why it prefers explicit error handling, and why it organizes code into modules, you stop feeling like Rust is just a list of rules. You start seeing it as a system. That is when the language really opens up. Now, if you enjoyed this content, like and subscribe. And that's all, folks.